Okay, so we're back for part B. And we had just finished talking, conjecturing that we were going to get 192 here.
Yeah.
Because you said, hey, every time we're multiplying by 4. Is there any geometric reason why that makes sense, or why the number of sides is being multiplied by 4 every time?
Well, because with our original triangle, every side was being multiplied. So you just formed a point on that side, and that created 4 sides for every one you had before.
Okay. So we have a pretty special rule here that says a straight line, no matter how it's tilted, turns into this. Yink, 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 yink. Right?
Yep.
So one side turns into 1, 2, 3, 4 sides.
Well, I think I see how that happens.
Oh, okay, good. How? How does that happen?
Well, like on this side here, when we had one long side, then we chopped it into thirds.
Yeah.
Then we had the midpoint of this. If this was done correctly, it would be the midpoint of the side you took away.
Okay.
Then bring it out, and then put 2 sides off of it.
Okay. Yeah, that's sort of the geometry that's going on. So every side, no matter what, and so on this stage, we counted the 48 here, right?
Yeah.
Now counting the 192 probably would take too long to do, but we can sort of see what's going on based on what you guys just said. We're going to. It is true that the point is above the midpoint, but I cut it into thirds. So each side now has 2, and then I could put that little spike on to make 3, 4, right?
Yep.
So it looks like I'm still cutting all my sides into 4, or sorry, turning every one side into 4 sides.
Yeah.
And if that pattern continues, my side lengths are all multiplied by 4.
Cool.
That's cool. What's happening, or sorry, the number of sides, not the side lengths, the number of sides. Now what's happening to the side lengths each time?
Well, you're dividing them by 3.
Dividing them by 3. Okay. So now the interesting question is to see what's happening to the perimeter.
Well, the perimeter, I don't see any real pattern in the perimeter.
Well, it seems like it's still getting bigger, even if the sides are less than 1.
Number of sides, we go times 4, and the side length divided by 3. Okay. So what's that going to do to the perimeter? How do I find the perimeter?
Well, you add up all of the side lengths.
All of the side lengths. What's another way to find the perimeter?
Well, if we take the number of sides and then we multiply it by what the side lengths are.
That's exactly right. So at any stage, if my side length is x, the perimeter goes to 4x, the number of sides,
4x
divided by 3. Now, is that going to be a bigger number or a smaller number? The perimeter, the first perimeter. Did I say this right?
Well, it's
Sorry, I said side length. The perimeter. If the perimeter at one stage is x, the new perimeter is 4x over 3. Okay. Now, so since I didn't explain that well, let me illustrate it with this example. 27 goes to 36. So does 27 times 4 divided by 3 equal 36?
Well, you can cancel a 3 with a 27.
Making what?
9.
9 times 4 is 36.
Okay, so sorry for not explaining that. Well, the perimeter, because of this rule, the side lengths the number of sides gets multiplied by 4, the side lengths gets divided by 3. If the perimeter is x at one stage, at the next stage it's 4x over 3. Is that a bigger number or a smaller number?
Well,
What do you think?
I think it's gonna keep getting bigger.
Okay, what do you think?
Well, it is going to keep getting bigger because 4/3 is bigger than 1.
4/3 is bigger than 1, okay. So let's see how much bigger it gets here. From 27 to 36, it gets how much bigger?
Is 9 bigger.
9 bigger. How much bigger does it get here from 36 to 80 to 36 to 48?
Well, it gets 12.
12, yeah.
How about from 48 to 64?
Then it gets 18. Wait, no. It gets 16 bigger.
16 bigger. Now, going from here to here, which should be the new perimeter should be 64 times 4/3, right?
Yeah.
64 times 4/3.
No, that doesn't look like it's going to be an integer.
No, rats. It's not going to be an integer, but that's fine because here the side lengths were 1,
Yeah.
and now when I divided them, I got 1/3. So it's not too surprising that it would have a third in it.
Yeah.
So 64 times 4, you know, is
256.
so it's 256 divided by 3, which is, let's see, 240 divided by 3, we know.
That's 80.
80 plus 16/3.
Well, that's almost 5. That's a little bit bigger than 5.
Right, in fact, it's 85 1/3.
So this is...
Okay. So 85 1/3 is, looks like 21 1/3 bigger. So not only is the perimeter getting bigger every time,
It's getting bigger by bigger numbers.
it's getting bigger by bigger numbers. So if we keep doing this forever, what's going to happen to the perimeter?
It's gonna get infinite.
The perimeter is going to get infinite,
But it's going to have a finite area.
but it is going to have a finite area. You can see what's happening on the board, and perhaps it's worth erasing a few things to highlight this point. Now, assuming I've drawn it right.
Yep.
Where did I go up to there, I guess? Then here, then here, then here, then here, then here. You can see I'm staying inside of a circle that's maybe that big.
Yeah.
Okay, so I don't know what the area is doing, but it seems to be staying inside of this circle, assuming I've drawn it right. So the perimeter gets infinitely long, but it always stays inside this finite area. Does that seem surprising?
Yeah.
Yeah.
How can you have something be infinite and another thing be finite?
Right, how can the length be infinite, but the area be finite?
It's infinitely finite.
It's infinitely finite, or
Finitely infinite.
finitely infinite. Seems strange, right?
Yeah.
Yeah.
I'm going to show you something we've 3D printed that illustrates this as well. Okay?
Oh, yeah.
Alright, let's go to the other room. And this is a very cool fractal.